All right. Hey, everyone. I'm Jacob from Phylax, and I'm the dev rel at Phylax. Today, I'll talk a little bit about how we can improve smart contract security with Assertions. So a little bit about who we are. We're a small team dedicated to solving security so that crypto can win. And what we're building is the credible security layer, which enables dapps to embed and verify to embed and verifiably enforce their rules in the base layer, enabling the world to deploy capital confidently. So why should you care about security? In 2024, we had plus 2 billion lost to hacks. Yes, small story. Usually, I never have my slides ready in like very good time, but actually these slides were ready on Thursday. So I had to put in a small edit with the 1.5 billion that was lost on Friday. And we're not even in March for 2025 yet. So yeah, we're definitely facing some problems with security in this space in general. And a tendency we're seeing is that the amount of hacks is going up. So except for the incident with Bybit on Friday, the amounts are usually a little bit smaller, but there are more hacks, which indicates that there are more projects, which is a good thing, but it also indicates that there are a lot of projects that don't care too much about security. So we should definitely fix this. Some of the ways people usually get their security improved is by audits, which is good. But the problem with audits is that they're very expensive, and often they're like a one-off event. So if you get an audit, that's good. Then a couple months later, you upgrade your smart contracts, and your audit is basically rendered invalid. All right. Another cool tool is formal verification, but it's difficult. It's not for everyone. It's difficult to write, and it's difficult to reason about it. And also, there is no such thing as perfect code. Like, all code has bugs. So that is just the hard facts. So what if I told you that you can basically improve your security without paying a lot of money to do it, and without learning some obscure formal verification language? So that is where the Phylax credible layer comes into play. And how does that work? You basically define what a hack looks like. So you can define a state that you don't want your smart contract to get into. And if you get into this state, that would basically mean that you have an invalid state. And what our software will do, it will basically revert or ignore the transaction that would result in this. So we're doing actual hack prevention instead of next block mitigation or whatever we have other projects doing. We don't have any additional trust assumptions in our system, so we're based on L2s, where you already trust the sequencer. So we implement at the base layer with the sequencer as part of the block builder. And we basically, we do simulate all transactions. So how it works is we take all the transactions that will go into the next block. Then off-chain, we simulate all the transactions. Then we compare the state after all these transactions and see if any of the transactions would get your smart contract into a state that you do not want. And if that is the case, we ignore the transaction that would lead to this state. So this is basically how we do hack prevention. And how do we define this? How do we define these hack preventions? We do that through what we call assertions. And assertions are written in very familiar syntax. You write them in Solidity using our credible STD library, which basically means you don't have any context switching as a Solidity developer. It's very familiar. You can call the same functions as you already have in your smart contracts, and you don't need to learn some obscure language for doing formal verification or whatever. What our library includes is a bunch of powerful precompiles that allow you to compare state before transactions and after transactions. So you could have a value before the transaction, and then after the transaction you can compare it. And if it, let's say, it's a price from an oracle that is going up more than 20% in one transaction, then that's probably something's wrong, and you could just ignore that transaction. You can also get all state changes in a call stack, for example, for a specific storage slot, which can be useful for, again, detecting price manipulation attacks, something like that. So you have a bunch of very powerful tools that you cannot, that you don't have in vanilla Solidity, so to speak. And as I mentioned, you define what a hack looks like. And the cool thing about this is you don't have to worry about all the edge cases that could lead to your protocol being hacked. You just have to know what a hack looks like. You can also kind of say, you just have to know the invariants in your code. And how you can think about this is as reverse intents. So you define a state you don't want to get your app into, but you don't care about how it actually gets there. And another thing, it is not part of your smart contracts, so you can deploy them after the fact. Let's say you deploy your smart contracts and you realize you forgot to add some check to one of your functions or something like that, then you can actually add that check with an assertion after the fact. And in the same way, you could say, okay, we have an owner of one of our smart contracts. We know that we probably will never want to change the owner, but in case of emergency, we will want to change it. And instead of letting all addresses being a potential new owner, you can define just one address up front that you know if we ever change the owner, it will be changed to this address. So that can kind of prevent that if anyone compromises your multisig or your owner address, then they can still only change it to one other address that you already control. So it's a very good way that you can put some control patterns into your smart contract as well. How does it work? You have the order flow of transactions, which is sent to the sequencer or builder. Then we have our sidecar that runs all these dapps rules against the unfinalized transactions, what I talked about before, where we basically simulate all the transactions and only include then the transaction that passed the rule set that we've defined with our assertions. So what I mentioned a little bit earlier was these invariants. So invariance it's very important when you are developing your smart contracts that you have an idea of the invariance that your protocol should always maintain. It's not a new concept per se, but a lot of people start focusing on this. We have this example from 2 weeks ago from Trail of Bits where they wrote a blog post about invariant-driven development and why it's so powerful. So in general, you should always, as a smart contract developer, you should know what are the invariants of my protocol that I never want to break. This is a very powerful thing to do and a very good exercise to do. But on the other hand, it's often quite expensive to always check all your invariants in your Solidity code directly. So that's where you can use our assertions to define the invariants and make sure they're always enforced without having to have all these expensive checks within your smart contracts directly. Basically, an assertion could define an invariant. It could be that you never want the C ratio of your lending protocol to go above 75% or something like that. And if there would ever be a transaction that would result in that, then it would be ignored. So that's in general something that you should always think about in your protocol is like having good invariants and having them well defined. And that is true for all projects. So what does an actual assertion look like? It's a small code snippet like this. In this case, this is an example that we could have used to prevent the Euler finance hack back in 2023. What happened was that they introduced a new function called donate into their protocol. And this function did not have a health check. So it didn't check if by donating that some positions got into deep water or underwater, sorry. So if you had an assertion that would always check this for all positions, then even if you forgot to add this check, the transactions that got the positions underwater would have still been prevented and the hack wouldn't have taken place. So here we have the example of an assertion that just checks for each modified account within a transaction if the position is still healthy. And this could have prevented something like the Euler finance hack, and it could also So I think a good example here is that even if you, after the fact, introduce some bug, then if you have a good invariant in place, it will always catch these mistakes that developers make. In a similar way, we have the ability to get state changes for all the calls in the call stack. So in this case, we're checking if an oracle that is reporting a price has any high deviations within the call stack of a transaction. So this could be in the case of a price manipulation attack. We can basically see, does anything happen within this transaction that looks like the price is being manipulated? In this case, we check if more than 10% deviation is taking place. And if it is, then probably something is wrong and the transaction will be ignored or reverted. So you basically, with this, you can really get in deep into your protocol and define things that you never want to happen without worrying about how exactly someone could be manipulating the price oracle. Okay, so where are we at the moment? We are just about to start our closed beta round with the Nemian phase. So if you're interested to learn a little bit more, come find me after the talk. We're also doing white glove onboarding at the moment, so we want to talk to a lot of protocols and understand what their invariants would be and how we can help them with assertions. And as that, like for that, we would also be happy to write some assertions for you if you're interested in exploring this further. And we also have a full demo where we can show all the things that's possible. So if anyone's interested in that, please contact me, reach out. So let's solve security, basically, so crypto can win. It's super important that we do better at this. I think that's all for me. Please reach out if you have any questions. I would love to get in touch. And also, if you are a skilled Rust developer, we are also hiring at the moment. I think that's all for me. Thank you very much.